So air emissions, VOCs, these arise from solvents or reagents with significant vapor pressure. We can categorize them into different classes depending on their toxicity and their impact on the environment. Okay, so condensing liquid and gaseous vapors. Most people are familiar with condensers to do this in the lab, and indeed we can use these in the plant. So typically we'd have primary condensers and cryogenic condensers to deal with very low boiling point materials, and we can see some of the operating parameters for both of those there. So these would be really about our first line of retainment for gaseous vapors, and we would condense these back to liquids and return them to the vessel, or put them into another vessel for recycling. And here's some of the advantages of cryogenic condensers, and indeed some of the disadvantages as well. Okay, after the condenser, any vapor that gets through the condensing process, we can deal with the so-called packed bed scrubber. And this is where we vent vapors through a liquid column, and that's generally a packed column designed for higher gas-liquid mixing. We can see some of the features of and advantages of packed bed scrubbers there. We can fill the scrubbers with different liquids, so it can be water, it might be an acid or a base to neutralize acidic or basic vapors, or we could put bleach in to destroy sulfur or phosphorus chemicals. Disadvantages, of course, we have to eventually dispose of the liquor that's in those scrubbers, so there is a waste disposal element here in using packed bed scrubbers. Carbon absorption. This is another technique that's used, and people may be familiar with this as a purification technique in liquid form, but you can pass gases through packed carbon beds to take out gases, and we can see some of the benefits and negatives of carbon absorption here. So odor control, VOC, recovery abatement, NOx abatement. We can treat wastewater with carbon to remove materials that won't biotreat and decompose. Acid gas removal. Okay, and we can see some more details about carbon absorption abatement technologies in this slide here. So catalytic oxidation, this is another way of dealing with gaseous emissions at the end of pipe, and this is very similar to a catalytic converter used on cars. So the gas stream is heated, it's passed through a catalyst bed, usually platinum or palladium. A rapid chemical reaction occurs, and the treated gas stream is mainly carbon dioxide with some nitrogenous materials in there. So in some cases, we can deal with a gaseous output just through dilution with nitrogen and vent into the atmosphere, depending on the nature of the material we're emitting, of course, and we need to be permitted to do that, of course. So typically installations are permitted as the total amounts of a particular VOC they can emit over a set time period, and a maximum rate of discharge as well. And these days, off gases from plants can be continuously monitored and quantitated by techniques like FTIR and FID.